Hi everybody, thank you for coming. So my name's Professor Chris Wallace. I'm relatively new to Cardiff Metropolitan. I came from the Royal Botanic Gardens Kew, and before that I was working in industry. I'm a professor in sustainable food science and technologies, and I also lead the Global Academy for Food Science, Safety and Security. And I suppose my background is one that since the days of my PhD has sort of filled that space between academia and industry. My PhD was funded by industry, trying to solve a challenge that they had within industry by using the fundamental science, I'm a chemist by training, to try and fill a gap in which they had in terms of a need that they wanted to fill. And after that, I did the usual process one does. I was a vagabond postdoc and got to see the world as a result, which I was very lucky and very fortunate to do. I wouldn't have had the means otherwise. And I suppose over time, my work drifted from more looking at how we can valorize raw materials, virgin raw materials, in a more sustainable way, to actually how we can valorize the waste or the byproducts from processes in a more sustainable and sometimes in a completely different, or in some cases a more innovative way or sustainable way than what we've done before. And I think that that's something that sort of has marked the process of the work that I've done in the last couple of years, working from everything from biodegradable plastics all the way through to looking at sort of how we can find new substrates for plants and the phytochemicals, the plant-based chemicals within them. And all of this, I suppose, links to this idea of de-fossilisation that we now have. So the idea is we all know that fossil fuels are going to run out, but we have a slight problem because if you're a chemist like me, you realize that almost every single chemical molecule we use can eventually be traced back to crude oil. So when we lose crude oil, we don't just lose the ability to put petrol in our cars, we lose the ability to be able to have toothpaste or shampoo or any of the other plethora of things that we take pretty much for granted as a result, including plastics and a load of other materials and resources we use as well. So we need to diversify where we get our raw materials from. That's without doubt one thing we need to do. But the other thing we need to do is we spent years and quite frankly millions of pounds, dollars, euros, whatever the currency may be, making sure that we took every last single carbon molecule out of crude oil and valorized it into some kind of product with, quite frankly, a level of efficiency and, dare I say, sustainability that is unmatched in any other process on planet Earth. But we don't do that with anything else. We don't do that with chemicals we take from plants. We don't do that with food. If you think about it, when you grow a tomato plant, you grow it only for the tomato. What do we do with the rest of the plant? We throw it away. Why? There's plenty of interesting phytochemicals in the leaves, in the stems, in the roots, all of which we ignore because we believe it has no value. And so part of the sustainable food science angle of what we're going to be researching here at Cardiff Met is looking at this idea of multi-harvests, looking at taking the philosophy, dare I say, of what we had for extracting products from crude oil and applying it now to more sustainable, more bio-renewable ways of producing products, whether that product be something we eat, whether that product be something that we put into a chemical, whether that product be something that we use to create a new material, to diversify the whole thing. So this idea of not only using things in a more efficient manner is something that we're very keen on, but then also looking at the ways in which, as I just explained with the tomato, that we valorize everything else from a single process that at the moment we don't valorize. So we call it waste, and that's a problem. Because once something is defined as waste, we as human beings have a connotation in our mind that it now has no value, and regulatory bodies, worse still, will often specify that we can't do certain things with it anymore, that then automatically means that it has no value. And I think one of the things that we need to do is generate a large data set of proof of concepts that in actual fact these byproducts from these processes actually have huge value in other ways. And one of the pieces of work that I wanted to talk about today was a project that we started already, which is called Fungi Dustbin. And I want to and the idea of this project is very simple, which is that what we want to look to try and do is take food waste, but food waste that's maybe also cooked, not just food waste that's raw and kitchen scraps and stuff like that, and now have a dustbin that is not only chemical in nature, but also living in nature, that can then be used to grow new sources of food, in this case alternative proteins. And we also want that process to be efficient enough that we can recover the water from it. In most of our food, 90% of what you're eating is actually water. So we need to get the water out as well, because if the increase in carbon dioxide is not going to be a major problem in the next few years, then the decrease in availability to fresh water is also going to compound those issues. So any new process that can take water that is good and healthy to eat or drink, we need to be extracting alongside other processes to, in this case, potentially grow new food. And this is a nice little project that we're working on right now with some summer students and some students moving next year, but it builds into a bigger philosophy of change that I believe underpins a lot of the work that we're going to do, which is this in the middle. Since Tudor times, we have basically treated our waste in exactly the same way. We do today what medieval people do, which is we take our waste, we put it in a container, and we bury it in the ground. And despite the fact that you may have recycling bags at home that maybe separate plastic, separate paper, maybe some of you have a green bag for doing anaerobic digestion of your waste, the majority of what goes in that black bag ends up going in the ground. And that's a problem. And it's a problem because it's one of the great blind spots that we have as a human race. We're all carrying advanced computers in our pockets. We all think AI is going to take our job, yet the most clever way we can deal with our waste is to put it in a bag and bury it in the ground. And this is what we need to try and get over in terms of the innovation, perhaps in a blind spot area that we're not thinking about. And Fungi Dustbin is a classic example of where we can try to innovate to show a proof of concept that we can, as a human race and as individuals, particularly in Western Europe, be more cleverer than just a plastic box that we then bury. And so this is part of the process and the theory of change that we want to try and build in through the research that we're going to do here at Cardiff Met, which is applied in nature, but still produces fundamental research that has the stereotypical, more classical academic publication background to it as well. So that's something that we want to try and develop and create here, and we believe that it will build into a philosophy of change, positive change, and build into a philosophy of international collaborations both within the university and beyond. Thank you for your time. I'm happy to answer any questions.